Okay, we're gonna go ahead and build the 10th step. So this is step 4. Okay, so there's step 10. So I'm gonna go ahead and add them up. Okay, so these are rows of 10, so 10, 20, 30, 40, 55. Now, I really don't want to build the 43rd step, so I'm going to have to use a little bit different method.
Okay, so we're going to have to come up with a formula here to figure out what is the number of cubes. So looking at the first one, and my hint was to look at it as a triangle. And a triangle, to find the square inches, you do 1/2 the base times the height. So let's see if it works out. So 1/2, this is 2, and then the number of rows is n, right? So we're going to say this is n, and then the height, it looks like is n. So it would be 1/2 n squared. So does that work out? So if I put in a 2, 1/2, 2 squared is 4, divided by 2 is 2. But see, this is wrong, isn't it? I should have got 3 because there's 3 there. So this didn't work. So maybe there's something a little bit. We need to make it a little bit bigger. So let's try multiplying by n plus 1. So this would be 1/2 2 times n plus 1. So 2 plus 1 is 3. So 2 divided by 2 is just 1, and I get 3. So this is the correct answer. And you can see that it will always work because if I take this whole thing and I flip it over, right, I just doubled it. So I'm looking for this area. But the area of this rectangle is n by n plus 1. And if I went to something like that, and I flipped it over, again you see this is n, and this is n plus 1. So if I get the area of this rectangle and divide it by 2, that would give me the area of this whole shape. So when I go to 43, so all I have is 43 and 44, right? Would be n plus 1. So it'd be 1/2 43 times 44. Half of 44 is 22. So I have 43 times 22. Not that. 6 and 8. 6 and 8. 14. So 946 would be the number there. Um, there is a legend of one mathematician by the name of Gauss, and he was kind of annoying in his class, and his teacher told him, go in the corner and add up all the numbers from 1 to 100. So you think 1 plus 2 plus 3 plus 4 all the way up to 100. And he came back, in less than 2 minutes, and he said, well, it's 5050. And the teacher was like, how did you come up with that? Well, he figured this out, that this is triangular numbers, that when you add 1 and add 2, it follows this pattern. And there's a quick way to add these up too. If you look at this, if you add the first and the last number, you get 101. And then what if you add the next number? So 2 plus 99, 2 plus 99 is also 101. And you see that all the numbers will be 101. So you take 101 times the number of pairs of numbers, right? So the number of pairs of numbers would be 50. And you see that would be 5050. But this is another way that you can look at the same expression, right? This expression was 1/2 n times n plus 1. But another way you could look at it is, well, you take the first number, which is 1, and the last number, which is 100. So that was n and 1, so n plus 1. And then you multiply it by the number of pairs, which would be the total number of numbers divided by 2, right? And you see that these are identical statements, that they're equivalent expressions. If you take a number and multiply it by that other number and divide it by 2, or take that number and multiply that number and divide it by 2, it's the same thing. So there's different equivalent expressions here. Now, if you multiply this thing out, actually, if you do n over 2 times n, you get n squared over 2, and then plus 1 times n over 2, which should be n over 2. And now we're entering into, before we looked at linear equations, which were only to the first power. Now we're looking at what we call quadratic equations that also have a second power. So we'll talk a little bit about that in this module. These are called polynomials. And the reason we call them quadratics when it's a square is because it works for the area model that we're looking at square inches, right? So quads are things with 4 sides. So that's kind of where we're starting.